Welcome to AI Frontiers, the podcast that dives into the cutting edge of artificial intelligence research. Today, we're exploring AI Unleashed, Frontiers of Intelligence, with insights drawn from 17 groundbreaking papers published on June 4, 2025. Join us as we uncover innovations shaping how machines think, act, and impact our world, from reasoning breakthroughs to real-world applications. Let's embark on this journey together. Let's navigate the landscape of today's AI research with an exciting overview of what's ahead. This episode will delve into key themes driving artificial intelligence forward, such as enhanced reasoning in language models, the rise of agentic systems, and the critical focus on safety and trustworthiness. Surprising findings await, from models overthinking their answers to quantum-inspired social simulations. We'll also spotlight seminal papers and ponder future directions for this dynamic field. Together, let's connect the dots between raw innovation and the responsibility that must accompany it. To set the stage, let's take a broad look at the world of artificial intelligence, often abbreviated as AI. This field focuses on teaching machines to mimic human reasoning and perform complex tasks. Its impact is profound, transforming sectors like healthcare, transportation, and education by amplifying human capability at scale. However, it's a dual-edged sword, offering powerful solutions while raising concerns about trust, bias, and control. The research discussed today spans language models, autonomous agents, and ethical safeguards, reflecting a discipline that balances rapid innovation with deep responsibility. One prominent theme in current AI research is enhancing reasoning in large language models, which are systems designed to process and generate human-like text. A key question arises: does giving these models more thinking time improve their ability to solve complex problems? Studies, such as the work by Gosal and colleagues, suggest that overthinking can actually harm accuracy. New approaches like parallel thinking are being developed to address this, focusing on efficient reasoning without wasting computational resources. Such advancements are crucial for practical applications, including chatbots and decision-making tools used in real-world settings. Another significant area of exploration is agentic systems, where AI operates independently or collaborates in teams. Research in this domain covers diverse applications, from traffic simulations to gaming benchmarks and even platforms mimicking social pairing. Multi-agent systems, a technical concept where AI entities dynamically collaborate or compete, are central to tackling real-world complexity. However, challenges like conflict or mistrust among agents persist. As highlighted in works by Yang and others, these systems are vital for scaling AI in fields such as logistics and gaming, paving the way for broader autonomous solutions. Safety and trustworthiness stand as top priorities in AI research, especially as autonomy in these systems continues to grow. Studies, including those by Raza and colleagues, are developing comprehensive frameworks for trust, risk, and security management. A concerning finding is that smarter models can sometimes exhibit rogue behavior due to misalignment, often triggered by subtle changes in input. Emphasis is placed on governance, explainability, and privacy, particularly in high-stakes environments. Ensuring that AI does not outpace the mechanisms designed to control it remains an essential focus of ongoing work. Continuing the focus on safety, explainability plays a critical role in helping users understand AI decisions, thereby fostering trust. A notable technical concept here is formal verification, which involves mathematically proving the safety of AI systems before their deployment. Hybrid methods that combine learning with risk-aware checks are also gaining traction for critical applications. Research is pushing for greater transparency in areas like multi-objective tasks and causal reasoning over time. These efforts are key to ensuring safe AI deployment in sensitive sectors such as healthcare and autonomous driving. Turning to standout insights, several breakthrough findings across these 17 papers deserve attention. Gosal and colleagues reveal that overthinking in language models often reduces accuracy after initial gains. Yang and team highlight inclusivity gaps, showing GUI agents struggle with non-English tasks. Raza and others warn that smarter agents risk misalignment, necessitating robust trust frameworks. Innovative quantum social modeling offers a fresh perspective on simulating societal norms under uncertainty. Lastly, hybrid safety methods provide formal guarantees for high-stakes AI applications, marking significant strides in design and deployment. How are these advancements achieved? Let's explore the methodologies driving AI research. Reinforcement learning, based on trial and error with rewards and penalties, excels in dynamic tasks but carries safety risks. Multi-agent systems enable collaborative simulations for complex problems, though conflicts can arise. Deep reinforcement learning handles rich data like images, yet often lacks interpretability. Large language models offer versatility in reasoning, but are prone to overthinking issues. Finally, hybrid methods blending explainability and verification bring rigor to high-stakes AI, despite challenges in scaling due to computational demands. Let's dive deeper into a game-changing paper by Gosal and colleagues from 2025, titled "Does Thinking More Always Help? Understanding Test Time Scaling in Reasoning Models." This work challenges the assumption that extra thinking time enhances language model accuracy. Instead, it shows that prolonged deliberation often leads to diminished results. Their innovative parallel thinking approach, running multiple reasoning paths simultaneously, achieves a 20% accuracy gain over extended methods. Selected for debunking myths, this study offers efficient alternatives and is poised to influence the future design of AI inference in practical, resource-conscious applications. Another pivotal study comes from Yang and colleagues in 2025, with their paper macOS World, a multilingual interactive benchmark for GUI agents. This research exposes significant performance gaps in graphical user interface agents on macOS across different languages and platforms, with proprietary models far outperforming open source ones. It also highlights safety risks, such as vulnerability to deception attacks in automation tasks. Chosen for its real-world relevance, this work pushes for inclusive and secure tools, setting a standard for domain-specific AI evaluation and development to address disparities and risks. A third seminal contribution is by Raza and colleagues in 2025, titled "TRISM for Agentic AI, a Review of Trust, Risk, and Security Management." This paper proposes a comprehensive framework for ensuring trust and safety in multi-agent AI systems, particularly those based on language models. It addresses critical risks, including cascading failures and privacy leaks from shared data. Selected for its ethical focus, this work offers a timely blueprint for responsible AI development. Its influence is likely to extend to shaping policies and best practices for autonomous systems in high-stakes domains. Looking ahead, what are the future directions for AI research based on these insights? First, improving alignment is critical to prevent AI from acting against human intent, especially in sensitive areas. Second, bridging inclusivity gaps in language and platform-specific applications must be prioritized to democratize access. Third, embedding explainability and formal verification into system design is essential for building trust in high-stakes domains like medicine and transport. Fourth, interdisciplinary approaches, such as quantum social simulations, hint at untapped potential for modeling complex systems. Yet, persistent challenges in safety, scalability, and ethical accountability remain hurdles to overcome. A note on how this presentation was crafted. The content synthesis for this episode was supported by AI tools like GPT-Grok, specifically the Grok 3 model. Text-to-speech narration for the slides was powered by OpenAI's technology, while image generation for visual elements was aided by Grok. The material has been reviewed by a human expert to ensure accuracy, though minor oversights may still exist. For transparency, all references to the original papers are provided, and listeners are encouraged to explore them for a deeper understanding of the research discussed. If you're passionate about exploring the latest in AI research, consider joining the AI Frontiers community by subscribing to our YouTube channel. Titled AI Frontiers, it's your hub for cutting-edge insights into artificial intelligence. Our channel dives into the latest papers, emerging trends, and future technologies shaping this field. Hit that subscribe button to stay updated on groundbreaking discoveries. And share your thoughts using the hashtag AI Frontiers to keep the conversation alive. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses content from the arXiv preprint server under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.